Afternoon, professors. I am Kelisha and I am from Lab P1 Group 3, and these are my teammates Zhenming, Han Yi, Rachel Wan, Rachel Poh, and Manesh. For this assignment, our team has decided to develop a real-time voting and polling platform named Rachel Square, where users are able to enter the poll code, vote, and view the results in real time. If you are wondering, this is how we came up with the name. These are the contents that we will be covering today. So firstly, we'll be starting with the product demo. So here is the home landing page of our voting website titled Rachel Square. So as you can see, here are the different polls that we have, and the user is able to search for a poll with the polling ID. So I'll be using the number 76908061, and it should give us the poll, What Does Duck Say? As you can see, the user would then be redirected to the polling page, and we can see the question, what does duck say? And a fun fact that has been generated with AI based on the questions. We can also see the polling choices. So now I'm going to just poll, and the user would then be able to see the polling results here on this page. Now I'll be passing the time over to Hani.
Okay, so users can also create new polls. So to do that, they need to log in first. They can also create a new account, but since we already created, we'll just log in. So once they have logged in, they'll redirect to a new poll, create new poll page. So we will just enter this question. So when was OpenAI founded? So I'll just list down some questions. All right. So when we create a poll, and we go back to the home page, you can see that it was newly created. So when we click on it, it will lead us to this page. So as you can see with this question, there's also a newly generated AI fun fact. And we'll just click on the answer, which is actually 2015, and we will see all the different the new poll is being created. So our application shows that, as you can see, it's very intuitive and it's very easy to navigate. You don't need a complicated user manual to navigate. And we also make use of the AI to make it very engaging and fun for the user to use. So now I'll pass on the time to Rachel, who wants to talk about the cloud architecture.
Moving on to cloud architecture, we have chosen to incorporate both IaaS and PaaS deployment models using services provided by AWS. So this is our system architecture diagram with a VPC spanning 3 availability zones for high availability. We have an EC2 instance running Apache in zone 1 to handle web traffic. We have also configured auto-scaling to dynamically adjust the number of EC2 instances based on demand, launching additional instances in other zones when needed. The traffic is then distributed by Elastic Load Balancer, and each zone has a NAT gateway for secure outbound traffic. And lastly, our RDS instance running PostgreSQL is in a private subnet, securely connected to the EC2 instances for reliable database access. Now, I'll pass the time to Rachel Poh to elaborate more on the security and availability aspects.
Moving on, we have created different security groups for our AWS resources. For our EC2 instances, we have allowed inbound rules of SSH, HTTP, HTTPS, and PostgreSQL from all traffic, whereas for our RDS, we have restricted inbound traffic to only PostgreSQL coming in from the EC2 instances in the other security group. To improve on the web application's availability, we opted for our resources to be hosted over 3 availability zones instead, with the EC2 instances being in the public subnets and the RDS being in the private subnets of these zones. We also have set up an application-level Elastic Load Balancer with an auto-scaling policy which would track the CPU utilization of the minimum 3 instances that we are running. With the average CPU utilization percent of 60 in consideration, the ELB will automatically add or remove instances in order to balance the traffic to our web application smoothly, therefore maintaining its availability. Next, I'll be handing over the time to Zhenming.
Hi, I am Zhenming/admin, and I'll be sharing the application setup portion for our project now. We use the LAMP stack for our project, LAMP, whereby L stands for Linux, and we have used Amazon Linux 2 as our operating system, and this is also a machine image option that is provided by EC2s. Next up, we have A for Apache, which is a web server software that we have installed within our EC2 instances to serve the static HTML, CSS, and JavaScript codes. Next up, we have M for MySQL, but we have instead opted to use PostgreSQL as our relational database instead, because this provides much more extensibility as well as some advanced features that we find it useful for our project. Lastly, we have P for PHP, which is a server-side scripting language that we have used to bridge our database to our front-end static HTML, CSS, and JavaScript codes. Moving on to the database setup is actually quite simple, as we have 4 tables that constitute our project. First up, we have the post table, where it keeps all the questions and selections. Next up, we have the users table, whereby every time a new user lands on our website, it will create a new row for the user. Thirdly, we have the votes table, where it will link the users to the post they have voted and also the answer they have selected. Lastly, we have the admins table, whereby the users in this table are authorized to create a new poll on our website. Lastly, I would like to share an additional effort that me and my team have worked on, which is the wireframing portion. Before we began any form of coding work, we have came together as a team to discuss what are the color schemes to use, what are the fonts to use, what are the functionalities that we want to deliver on our website. And we have put together all this discussion into a wireframe prototype as you are seeing here. And this has allowed us to improve our efficiency and productivity in coding. And most importantly, it allowed us to deliver a high quality work that we are extremely proud of. That's all from my end. I'll be passing the time to Manesh now.
Thank you, Zhenming. For the performance analysis, firstly, I'll be covering the different traffic simulation tests that we have conducted. We simulated 3 low traffic scenarios, followed by a normal average traffic scenario using Apache JMeter, and we can see that the application is able to handle the traffic well, with the peak CPU utilization being at around 50%. Next, to test the performance and scalability of our application under high traffic, we first reduced the scaling policy threshold to a much lower limit to prevent any account budget depletion. We then use Apache JMeter to simulate a traffic spike, and consequently, we can see that the load balancer created multiple new instances in order to accommodate and distribute traffic accordingly. To test the system's fault tolerance, we simulated potential failure scenarios. In the case of an EC2 instance failure, we ensured that the system employs auto-launch capabilities for replacements to minimize any downtime. For RDS failures, the system is configured with multi-availability zone failover, where in the case where an issue arises in the primary database, the service switches to a standby instance in a different availability zone, ensuring integrity and availability of the database. Now, I'll be passing on my time to Han Yi, who will be closing off our presentation with our application's unique selling points.
Now, let's cover our unique selling point of our project. So, besides developing a real-time voting system, we intentionally included these 3 points to our design. Firstly, we integrated AI to generate our fun fact to our voting questions, as you've seen earlier in the demo. So this is an additional consideration we want to provide for our users with more information to the question, which are helpful and engaging too. Next, we ensure our design is minimalistic. As you see in the wireframe earlier, we included a wider space and a lighter background, which makes it more comfortable when viewing our website. And lastly, we designed our website to be very intuitive for users. It is not complicated to navigate around, and it is very straightforward without the need of a user manual. So we have come to the end of our presentation. Thank you for listening and have a good day.